All right, today we're going to look at the day 2 of how to solve quadratics by completing the square. So just a reminder that we can use some properties of equality to manipulate an equation until we can make one side into a perfect square. And we call this process completing the square. So the way we can do that, the way we can complete the square is, first of all, if our a is not equal to 1, we want to make our a into 1. So we're going to divide the equation by the a term. And then we're going to move the constant term to the right side of the equal sign. And then we're going to take half of the middle term, we're going to square it, and we're going to add it to both sides. And then, of course, we can simplify that right side because it's going to be two constants that are going to be added together. Factor the left side into a perfect square trinomial, and then we square root both sides and solve for x, just like we did yesterday. So up until step 4, that's going to be the new part, and then once we get to step 5, that's just a repeat of what we did in the last lesson. So let's look at how this plays out. So for our first example, of course, we're going to start off with a little bit easier one. So we're going to start off with an a of 1, so we can skip step 1, and we're going to move on to step 2, which is to move that constant term to the other side. So that becomes x squared plus 18x equals 4. Now I'm eventually going to factor this into a perfect square trinomial. X is going to be my first term, and when I factor that, what's going to be my second term is going to be what's half of my b term. My b term is 18, so half of 18 is 9. And then my c term here in the previous step, I'm going to add to that the same term to both sides. So I make a little box to remind me that I need to do that to both sides. And what goes in the box is going to be that 9 squared. So in this case, 81. I'm going to add 81 to both sides. And if you look, x squared plus 18x plus 81 does factor down to x plus 9 squared. Take the square root of the first term, square root of the last term. The sign in front of the 18 that tells us is plus, so that's how we get that x plus 9 squared. The right side is 4 plus 81, so that is 85. Now, we can go ahead and take the square root of both sides. And since it's my choice to take the square root, I'm adding and subtracting. It's a positive and a negative. So I get x plus 9 on the left equals plus or minus square root of 85 on the right. Now, can't do anything with that plus or minus square root of 85 as far as simplifying it, so we're just going to leave it as is. And the last thing I can do is x equals negative 9 plus or minus square root of 85. And that's all I can do. All right. So now let's look at one a little bit more advanced. Still not too bad. So I will warn you, some of these on your homework do get a little bit hairy. Just be patient. You'll be okay. The ones on the notes, though, this one is going to be a little bit more intense than the last one, but still nothing too bad. First step is we are going to divide by 4. So we need our a to be 1. So we're going to divide both sides by 4. So that's x squared minus 3x. Now, negative 27 divided by 4 does not simplify, so we're going to leave that as negative 27 fourths. And 0 divided by 4 is 0. All right, so next step is to get the constant to the other side. So that equals 27 fourths. The next step would be to factor that in perfect square trinomial. So I know that my half of my c term is going to go here in the parentheses with that, so that's negative 3 over 2. And this is going to be plus a box, and inside the box is going to go the square of negative 3 halves. Negative 3 halves squared, to square the top, you get 9. Square the bottom, you get 4, so 9 fourths. And of course, that's positive. So 27 fourths plus 9 fourths, common denominator, so we can go ahead and add the tops. So 27 plus 9 is 36 over 4. And that does simplify down to 36 divided by 4 is 9. So nice and round number there. Square root both sides to get x minus 3 halves equals plus or minus the square root of 9 is 3. So x is equal to 3/2 plus or minus 3. We can go ahead and simplify that because those are both real rational numbers. 3/2 plus 3 is 9/2. 3/2 minus 3 is negative 3/2, and those are our two solutions. And that's our final answer. All right. So let's take a look now at this next part. Next example 3, we want to divide both sides by 3. So we get x squared minus 24x plus 155 equals 0. And now we're going to get the constant term to the other side. Equals negative 155. So when I factor that, negative 24 divided by 2 is negative 12. And negative 12 squared is what's going to go in the box, and that is 144. The thing in the box will always be positive because it's being squared. Anytime you square any number, whether it's positive or negative, it becomes positive. So we're adding 144. So negative 155 plus 144, that is negative 11. Now, I want to get rid of the square root. So we're going to take positive and negative square root of negative 11. X minus 12 is equal to, the only thing I can do to simplify that is I can go ahead and pull an I out because there's a negative inside the square root, so it becomes an I. And then, last step, add 12 to both sides, so you get 12 plus or minus the square root of 11I. All right. So, next thing we're going to look at is a little different. We're going to be converting from standard form into vertex form. So we've already talked about how to go from vertex form into standard form. In the last unit, we covered that. So now we're going to talk about how to go the other way and go from standard form into vertex form. And we can actually use completing the square to do that. It's kind of nice. All we have to do is change our y into 0. So x squared plus 8x minus 3 equals 0. And then we just complete the square. We will stop, though, before we get to the taking the square root of both sides. So we get x squared plus 8x equals 3. Then I'm going to put that in parentheses. Half of 8 is 4. 4 squared is 16. So 3 plus 16 is 19. So this is where I would normally take the square root of both sides, but I don't need to get x by itself. That would be finding the x-intercepts, and I don't care about the x-intercepts at this point. I'm just looking for vertex form. So I need to get this back equal to 0 now. So I'm going to subtract 19 off of both sides, and I get x plus 4 squared minus 19 equals 0. So my vertex form is that, x plus 4 squared minus 19. And of course, then I know my vertex is negative 4, negative 19. All right, so now let's look at this one, negative 3x squared minus 6x minus 9. So we're going to do the same thing. Negative 3x squared minus 6x minus 9 equals 0. Divide everything by negative 3. Get x squared plus 2x plus 3 equals 0. All right, so now we are going to turn that into a, first thing we got to do is move that 3 over. Make that negative 3 equals negative 3. Go ahead and factor that into a perfect square trinomial. Half of 2 is 1. 1 squared is 1. And negative 3 plus 1 is negative 2. So from here, again, I want to make that equal 0. Now, the only thing that I need left to do before I turn this back in to vertex form is I need to make sure that my A's match up. My A in my standard form is -3. That means the A of my vertex form needs to be -3 as well. So we're going to multiply both sides by -3. So that becomes -3 parentheses x plus 1 squared plus 6 equals, oh, sorry, that was supposed to be a positive 2, and this is a -6 equals 0. So our function is y equals -3 parentheses x plus 1 squared minus 6. And that's our final answer. Our vertex then, just from looking at this, we could tell our vertex is at -1, comma, -6. All right. Well, that is the notes for today. If you have any questions, please shoot me an email or a Canvas message. I'll get back to you as soon as I can. Have a wonderful day.